Hello, welcome. In this short video, let us look at the definition of problem of linear regression. The problem of linear regression can be concisely defined as follows. It basically consists of a training data set which has two components. The first one is a set of input features, and each of these features can be a vector of m dimensions, or it can be simply a scalar. And then the second component is a set of target values that correspond to these input features or input feature vectors. So the goal of the problem, or the goal of the linear regression problem, is to find a mapping from these input features to the target values and use this mapping y to predict the target values of new feature vectors that are not a part of the training data set. For example, this plot shows a sample input features and the corresponding target values. So here we only have one-dimensional features, and we can clearly see that the input features are related to target values by a linear relation. So our goal is to approximate this. For real-world data, we know that there is always a generating function that produces the target values from the original input features. So the goal of linear regression is to find a linear model that depicts this process or approximates this process. So these are some of the linear models that approximate the generation process. That is, for example, this is the simplest linear model. That is y of x comma w, where w is a vector of weights. This is a simple linear combination of the weights and the input features. For example, the m-dimensional input feature vector here. So, and a generalization of this relation of this model is a linear combination of the weights with the nonlinear transformations of the input features. And there is always an offset between the y of x comma w and this linear combination, which is independent of the observations or which is independent of the input features. So we can actually include this bias or this offset, usually known as bias, into the linear combination by just introducing a dummy basis function that has value 1 for all input features. So the general linear model can be written as follows. That is, we have linear weights and the basis functions phi of x, where phi is a nonlinear feature transformation function, usually a nonlinear transformation function. Let us look at an example illustrating the linear regression problem. We have a vector of input features, that is temperature in Fahrenheit, and a vector of target values, which basically represent chirps per second of a striped ground cricket. Now the goal of this linear regression problem is to find a linear relation between the temperature, the surrounding temperature, and the chirps per second of the cricket. So from this available data, we can clearly see that there is a linear relation between temperature and chirps, which is given by this model. And this linear relation can be determined by one of the existing optimization approaches for solving a linear regression problem. And coming back to the general linear model, that is the basis functions, some of the basis functions that are commonly used are, the first one is polynomial basis functions, where we can have polynomial of degrees from 1 to say 10. So this one, the blue line, basically depicts the polynomial of degree 1. The transformation phi of x is same as x. And for I greater than 1, that is for 2, 3, and so on, the transformation is basically quadratic, cubic, and so on. And the next set of basis functions are Gaussian basis functions, where the input feature vectors are transformed by using this Gaussian function, and by choosing mu and b carefully, we can properly look at the basis function. And the next common basis functions are sigmoid basis, where we use the sigmoid transformation or sigmoid function for transforming the input features into the new feature space, and by choosing the values mu and s, we can determine the location of the sigmoid transformation. Note that even though the input features are transformed by nonlinear functions, that is, the model y of x comma w or the function y of x comma w is a nonlinear function of the input features, but it is a linear function of the weights w. The goal of the linear regression problem is to determine these weights w that optimize, or that is, maximize or minimize a certain chosen cost function. So thus, to summarize, the linear regression problem can be defined as, we basically have a set of training data which has two components. The first one is set of input features, and second one is a set of target values. Now goal is to find a mapping from the inputs to the outputs or the target values, and then use this mapping to determine or predict the possible target values of the new unseen features. Thanks for watching.